All right, good afternoon, guys. I hope you're all doing well. My baby has been born. She's doing great. She came in at 7 pounds, 1 ounce, 19 inches, which is awesome for being 3 weeks early. She's eating well. Everything's going great. So thank you guys for your thoughts and prayers. But we got some stats to do. So with us all, I just found out on last Wednesday, so a week ago, that we were having the baby on Sunday. So I didn't have everything prepared ahead of time. So I had to make some videos while on leave. You didn't need to know that. But anyways, here we go. So let's go ahead and get started on this lesson. I hope 4.1 made sense about how to collect data and whatnot. I was looking over your projects that you started already, kind of like your outlines and ideas, or some of you guys have to tweak some things. You didn't fully understand what it meant by what question are you trying to answer in regards to bias. So I'll email your group about that so you guys can be aware. Or actually, what I'll do is I'll just make a comment in that doc, and you'll be able to see that, okay? And I'll mention your name so you know which group I'm talking to. But yeah, a lot of you guys had some really good ideas. I was very impressed. So hopefully you guys are understanding that. If you have any questions, feel free to email me. I'll do my best to answer what I can. 4.2 talks about experiments. Today's lesson is going to be very definition heavy, kind of just explaining what these certain words are that we're going to be using and some of the processes that we go through, but mostly it's definition and a lot of vocabulary. So not the most exciting lesson. Not that you guys have thought this class is very exciting either, apparently. So it is what it is, I suppose. Let me go ahead and share my screen with you guys. I'm just kidding. All right, so we got that there. Slideshow. All right, 4.2, talking about experiments. Let me move this up here real quick. And just kind of like the definitions of words that we use in experiments. So first off, your learning targets are to be able to explain the concept of confounding variables and how we can use, or just confounding in general, and how we can use that to, or how that can be limiting our ability to make cause and effect conclusions. When you do an experiment, you're trying to say, does one thing cause a certain effect, right? So like, for instance, one of your guys' groups were, does wearing Nike indicate what type of shoe is your favorite, right? Something like that. You're looking for a cause and an effect. So that's what that's what an experiment tries to do. You want to be able to distinguish between observational study and an experiment, and identify the explanatory and response variables in each type of study, which you guys should be good at that because we are kind of are aware of those. Identify experimental units and treatments, and describe the placebo effect and the purpose of blinding in an experiment. This is a 4-lesson section, so lots of work to do in this section. Describe how to randomly assign treatments in an experiment using slips of paper, technology, or a table of random digits. You guys can read this. Pause it if you need to. Okay, I'm moving on. All right, so sample surveys are a kind of observational study. All right, so observational studies can examine already pre-existing data. So for instance, you have data and you simply just look at it and make observations based on it. It's a prospective observational study. If you take a group of individuals that have already had data collected on them and you track them into the future, that's called a prospective observational study. So an example of an observational study is taking a vitamin D supplement good for you. Hundreds of observational studies have looked at the relationship between vitamin D concentration in a person's blood and various health outcomes. So for instance, we can look at some data that's already been established where they look at what vitamin D does for the body and look into those things, right? That's called an observational study, where you just have something, you look at the data and see if it has an effect. But it does not attempt to. Oh, yeah. So you're not trying to see if one thing, for instance, an experiment, right, would be taking a placebo effect and a vitamin D, or a placebo pill, which is like a bread pill. It doesn't really do anything. You give both pills to groups of people and see how the different people respond, right? That would be an experiment where you're trying to see if one thing affects another. Whereas an observational study simply says, let's look at all of these people. Look, all of these people have taken vitamin D. Now let's ask them questions about their happiness level, right? Or their health. That's an observational study. We're just making an observation based on things that have already happened. An experiment goes and tries to have variables where they can compare two sets of data. Hopefully that makes sense. All right. A response variable measures an outcome of a study, whereas an explanatory variable may help explain or predict changes in a response variable. So for instance, one variable may be vitamin D, and that'd be the explanatory variable, and the response variable would be level of happiness, right? Or physical health or mental health. Hopefully that makes sense. Or I guess in this case, our response variable would be diabetes, and the explanatory would be vitamin D. Anyways, so this observational study here, right? It shows a variable of vitamin D. Group 1 has high vitamin D, group 2 has low, and you're trying to see what conclusions can we make, right? So we have a diabetes response is our response variable, and then the two possible outcomes are you're less likely to have diabetes or more likely, okay? They're looking at just data. Now, confounding variables, or just confounding in general, occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. So, for instance, when we look at the variable of having high vitamin D or low vitamin D, can we see a difference? It'd be called confounding if we don't, all right? Now, if you wanted to actually determine if it made a difference, someone could run an experiment. An experiment would, for instance, be like this. The researchers randomly assigned 500 people with pre-diabetes to either take a high dose of vitamin D or take a placebo, like a bread pill, which I mentioned earlier. A pill that looked exactly like the other one, but contains no active ingredient. After 5 years, 40% of the people in each group were diagnosed with diabetes. So was there a clear and obvious difference between an effect that the vitamin D pill had on diabetes? No. So we'd call those confounding. All right. But that's an experiment because we intentionally put the variables into place. We didn't just observe something. All right. Here are a couple of terms. So I already explained. Hopefully you understand those. Pause me if you need to write them down. All right. So next, an experiment is a statistical study in which we actually do something or force a treatment to people, animals, or objects, and the experimental units or subjects to observe the response. So I take some kind of treatment, some kind of variable, and I apply that to a group of individuals. That is an experiment, and I want to see what the response is. A specific condition applied to individuals is called a treatment. You can write and read these if you need to. And an experimental unit is the object to which treatment is randomly assigned. So for instance, my treatment would be assigning a placebo or assigning a vitamin D pill. And my experimental unit would be the people that received these pills. They're also sometimes called subjects. Hopefully you're understanding that. All right, so here's an example of an experiment. Malaria causes hundreds of thousands of deaths each year, with many of the victims being children. Will regularly screening children for the malaria parasite and treating those who test positive reduce the proportion of children who develop the disease? Researchers worked with children in 101 schools in Kenya, randomly assigned half the schools to receive regular screenings and follow-up treatments, and the remaining schools received no regular screening. Children at all 101 schools were tested for malaria at the end of the study. So what would the treatments and experimental units be? I'll pause. Actually, you just pause me and answer that question. Okay, hopefully you pause me. All right, our experimental units, the things that we are testing, are the 101 schools in Kenya. And then the treatments would be the two things that were applied to these groups. Regular screenings and follow-up treatments would be one, and the second would be no regular screening. Pretty straightforward, right? Hopefully you guys, that makes sense to you. Now, a factor would be a variable that is manipulated and may cause a change in the response variable, right? So I know that sometimes we consider factors to be different things in math. Statistics, this would be a factor. The different values of a factor are called levels. So, for instance, in this study, researchers from Rutgers University put the 5-second rule to the test. They used 4 different types of food: watermelon bread, bread with butter, and gummy candy. They dropped the food onto 4 different surfaces: steel, ceramic tile, wood, and carpet. And they waited for 4 different lengths of time: less than 1 second, 5 seconds, 30 seconds, and 300. Finally, they used bacteria prepared 2 different ways: in a tryptic soy broth or peptone buffer. Once the bacteria were ready, the researchers spread them out on the different surfaces and started dropping food. List the factors in this experiment and the number of levels for each factor. So our factors would be, well, I'll pause it. See if you can read the definition and understand it for yourself. Okay. Factor 1 would be the type of surface, the types of foods. And that factor of food would contain watermelon, bread with butter, and gummy candy. So our factor would be type of food with 4 levels. Okay. Hopefully that makes sense. Then our second factor would be the surface that things are dropped onto. So stainless steel, ceramic tile, wood, and carpet, also 4 levels. So a factor of type surface with 4 levels. The next would be the time that it was on the ground. 1 second, 5 second, 30 seconds, and 300 seconds. So we also had another factor, which is time on the ground with 4 levels again. So all 4 of these factors we also have 4 levels. You're comparing many different things and you get lots of different results. Oh, I'm sorry. And the bacterial prep, which has 2 levels. So you have the soy broth and the peptone buffer, 2 levels for that one. All right. Now, when you design an experiment, good designs are essential for effective experiments, just as they are for sampling. To see why I start with things, yada, yada. When I wrote this a long time ago, or grabbed it, I was far less confident in what I was doing. Okay. So first thing you need to do is find your experimental units. What are you studying? Your treatment, which means like, how are you going to study them? And then you measure the response to collect your data. Okay. All of these things must be done. There are many other variables besides the treatment that are, oh, wait, where did this go? Oh, this is to match the book. We're skipping through this a little bit, but essentially this is how you design your study. Okay. So you're actually going to write this down for your project that you're working on. What are your experimental units, your treatment, and how are you going to measure your response? That's going to be our next step for your study. Don't worry about that. Okay. Now, the next thing you want to go over is in an experiment, what is a control group? Your control group is like what you compare your variable, right? What do you compare your variable against? We often do this by giving a placebo effect. So for instance, if we're doing a study, you want to say, I want to compare the effects of this drug to someone who doesn't have this drug, right? So I know if it actually makes a difference. Because if we just gave everybody the vitamin D drug and then just measured everybody and saw how they were doing, right? Then we're not going to really know if they're doing better than the random person. So we also have other people that we say we're giving a drug to, and then we see, did this actually have an effect? Because sometimes people will think they're doing better, or they'll give a false response kind of, just because they've taken a pill. So we want to compare it to 2 different things and see if it makes a difference. That's called a control group. So the group that you get that placebo effect to would be your control. Or sometimes you don't even give a placebo, you just have a group that you don't tell anything to, right? So for instance, I could have regular Wisconsin soil, right? I just grab it out of the ground and I plop it on a desk and put some seeds in it. Then I also have soil treated with a fertilizer, right? Maybe have some kind of chemical fertilizer and I pour some seeds into that. Then I also have some soil, I grabbed it out of the ground and I threw some pesticides on it. And then I threw the seeds in there and see how that grows. Then I also have a soil that I put some cow manure on, and then I see how that grows, right? My control group is be the regular soil that I grabbed out of the ground and didn't do anything to. And I can compare the other groups to that control and see how the plants grew based on what type of soil they were in. Hopefully that makes sense. Should be something you're relatively familiar with. But everything else should be exactly the same. So you'd grab the 4 scoops of soil from spots right next to each other. And then you water them the same. You give them the same amount of sunlight. So that way, the only thing you're testing would, in this case, just be the treatment you give to the soil. Yep. Okay. So it just allows you to safely say that you are confident that that variable or that treatment that you implemented actually had an impact on your experiment or on your subjects. Did I want to get into this yet? Nope, that's where I was going to stop for the day. Okay. I actually went a little bit too far. That's okay. All right. So that's 4.2a. That's Friday's work. Your work will be posted to Google Classroom. And I hope you guys are doing great. I look forward to seeing you in 1 week and 3 days. So have a great day, and I'll catch you guys later. Boom, 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 boom. Stopping. Stop share. Come on, stop record. See ya.